Okay. Well, thank you all for having me here for this to give this talk. I'm Mike Butler from the Algorithm Scientific Software Integration and System Transition Team, or ASSIST. So I'll be talking about how we've been collaborating with CSPP Geo on their Level 2 product software. So I'm the integration lead on ASSIST. Also listed here are the other members that have participated in this collaboration, from the science quality assurance to the Python developers, as well as the management that has been overseeing this. So this is the general outline of what I'll be talking about. First, going over what ASSIST's role is in the transition from research to operations. I'll be talking about the framework version 2 software, just an overview and highlights of how we've been using that in our collaboration with CSPP Geo. I'll be talking about the most recent and some upcoming deliveries that we've been working on to support future releases of CSPP Geo. I'll mention some of the new features and modifications we're going to be making to those products, and just summarize at the end with some comments on future directions that ASSIST is moving toward and what that means for future deliveries. So this slide kind of gives an overview of the research to operations process and where ASSIST falls in that. So we start with the delivery of the science algorithms from the AWG. They pass it to our integration team, and we do our updates, integrating it into the framework, ensuring coding standards are met, and conducting lifecycle reviews depending on the operational platform. Once the algorithm has been integrated into the framework, we pass it on to the Python development team. They implement it in near real-time processing using the same production rules and platform specifications of the operational platform. So once we validate that processing is happening as expected, we make the delivery to operations. So the main software that we use to make the main software that we integrate these science algorithms into is referred to as the NOAA STAR Algorithm Services Framework, or ASF, version 2.0, formerly called the STAR Algorithm Processing Framework. But this is just a single software framework with common interfaces for running and managing the precedence of large sets of enterprise multi-satellite algorithms. So that the fact that we support multiple satellites and multiple missions requires the framework software infrastructure to be versatile, easily extensible, and feature-rich. So I won't get too much into the technical details of how the framework works, but this is just a one-slide summary of how the different components, I guess, of the framework. So we have the integration API. That is the interface between the science algorithm and the framework software. So we support multiple languages, Fortran, C, and C++, and Python. And they interact with the framework through the configuration system. So we use XML files to specify what all the inputs and possible outputs of a algorithm are. And the framework parses these to construct execution graphs for varying configurations supporting multi-satellite, as well as temporal execution. So once the configuration is in the framework, it determines a schedule and executes the algorithm in order of precedence, so that all the downstream products have the inputs they need. either in the data cache or netcdf files. And this is just a simple diagram of how that might look. So we have two tasks, inheriting or receiving input from an upstream algorithm, for example, from the level 1B reader. And task B needs a output from task A to run. So the framework will run task A, produce what task B needs, and then execute task B, and then finally produce the desired output. This is just a slightly more detailed diagram of how that works. I won't go into too much detail on this, but we start at the top left with the XML configuration, which invokes the task scheduler that will process the algorithms, and through the various framework APIs, it will basically run what needs to be run to generate all the upstream inputs for the algorithm and place it in the data cache or output it to the netcdf files. So when we prepare dApps to CSP Geo, they're delivered as a subset of the framework. So during the normal transition to operations lifecycle, we help to verify and validate the algorithm updates. So the initial validation is done between the ASSIST integration team and the science team. And we also do more in-depth validation between the framework output and the operational platform once we deliver it as part of the lifecycle reviews that we do. But prior to preparing a new dApp for CSPP Geo, we first coordinate with them to identify what capabilities, modifications, or fixes are required for the delivery. So once we have that worked out, we begin preparing a subset of the framework code. So the framework contains a large number of algorithms, both product algorithms and ancillary algorithms. So to simplify the delivery, we extract only the algorithms needed to process the products needed. So once we have that subset of the framework created, we pass it on to the Python development team, and they wrap the static executable in their Python driver scripts and create a series of test cases to support all the satellites and coverages that are needed. So once that's all been validated internally, we deliver the dApp, including the source code, those test cases, and all the relevant documentation to CSPP Geo. So after the delivery has been made to CSPP Geo and they get it implemented, we start to run the framework, the new real-time executable, as well as the CSPP executable in a container, as well as on our local Linux machines. And we conduct a series of comparisons between the CSPP team and ASSIST. So on the right, I have some examples that Huaji presented at the 2019 CSPP meeting. So we compare our framework results to the CSPP results, as well as the ASSIST results using the CSPP executable to the CSPP results. So any differences are flagged, and we examine them to determine if there's an implementation issue that needs to be fixed by a patch or a cherry pick from our Git repository. But if everything's implemented correctly, we should only see differences caused by running on different machines in different environments, basic machine noise. So once we finish validating that, we can say that it's ready to proceed. So these are the currently supported products as of the last beta that Graham mentioned. So we have these cloud products for the mask phase, height, decomp and encomp, aerosols. We have the LST, FLS, and WINS. And we also include all the ancillary algorithms like the level 1B reader, GFS, CRTM, and the static masks included in the subset. So just to give a preview to what we are working on to support the version 3 release. So we made the latest delivery for that in May. Some of the highlights that we included, we updated them all to the latest science version that is currently running in the ground system operationally. We added GOES 17 support for those that were not missing it. We also added the preliminary GOES 18 support, as well as support for 3 new algorithms, sounding, cloud cover layers, and enterprise rainfall rates, which is going to be delivered in a separate patch in July. One of the other changes we made to all the products is enabling a more PUG format-friendly output. We don't follow that standard exactly, but we have added the capability if that is desired. So in these new outputs, we've removed the latitude and longitude arrays from all the products and added the gridding coordinates X and Y and the projection information. And in the CMI output, we thinned those and only output the needed variables. These are just some quick images I made of some GOES 18 data from a couple days ago for the new products. This is cloud cover layers. A couple of variables from the sounding product, the skin temperature and total precipitable water, and then rain rate, which is yet to be delivered. So most of those are still using GOES 16 lookup tables. I'll talk about that a little bit later. So I also did some analysis on the latest deliveries performance. So I ran one case outputting all these 13 supported CSPP Geo algorithms, plus the CMI and a geolocation file, using the same format that we would have used for the earlier deliveries, version 2 and earlier. Basically the same standard that's used in NDE and CCF. And then I used the trim versions that we delivered in our most recent delivery. So the biggest difference we found was for a full disk GOES 18 scene, using the new output configurations, we save almost 20% in file size just by removing that latitude and longitude information from the products and the trimmed CMI. There was only a very minor impact on the total runtime just for I/O. So we have a few more things that we need to do for the version 3 deliveries. So like I mentioned, the rain rate algorithm was not included in the initial delivery while we sort out some issues we were having with the offline when I say offline, it's outside of the framework. We were working through some issues with the scripting on that, so we'll be delivering that patch in about a month, containing both the offline portion and the framework rain rate algorithm. We will be delivering any GOES 18 related lookup table updates if and when necessary. Like I said, currently the GOES 18 processing, we're currently using placeholder copies of the GOES 16 lookup tables and thresholds as we were advised to by most of the science teams. That might be reevaluated once GOES 18 becomes operational. Two tables we did receive were for the enterprise cloud phase thresholds. Those were received and shared to CSPP Geo and the ground system. There's a upcoming GOES 18 lookup table for AOD that we're currently preparing to deliver to GOES our ground system and CSPP. So in the long term, for ASSIST, we're looking to move away from large single software frameworks like the ASF version 2 toward a more standalone approach. This is to help support the cloud service-based processing that we're planning to move toward with NCCF. Once we get, we're also looking to get to implement a continuous integration and continuous delivery model that will allow the science teams to collaborate more closely with us at ASSIST. But yeah, the orchestration system to enable this is still a pretty early in the development cycle. So the details of how this will impact future deliveries to the ground system and CSPP Geo remain to be determined. But once we do have those details, we'll share those as well as any information on the training we'll need to provide to support that. So to summarize, the framework we've been developing and using has enabled us to collaborate closely and smoothly with CSPP Geo on large packages of algorithms. Recently, we've been working on adding more streamlined outputs and increasing the number of algorithms supported in CSPP Geo. And yeah, like I mentioned, we're having this shift towards more standalone algorithm deliveries in containerized packages rather than these large dApps. But more to come on that as that develops. But yeah, that's all I have. Thanks.
Thank you, Michael. Are there any questions? Yes, Andy?
Yeah, this is maybe a little tangential, but I know the GOES program is thinking about as a project to reprocess the level ones. And, you know, the next question will be reprocessing the level twos. Do you think this move to the cloud and what you're doing will facilitate that, or do you think that would be a totally separate solution?
Yeah, I'm not sure.
Any other questions for Mike?
Hey, Mike, I want to thank you for, first of all the help we've got from the ASSIST team over the years with CSPP Geo. You know, you can imagine the project working out any number of different ways, not really as well if we hadn't had your group to work with. You know, if we were trying to work with each science team separately, that would be painful for both them and us. So it's worked out very well for us. We appreciate the collaboration and the level of support you provided. Thank you for coming here and giving a talk, truly. So I guess, I don't know if it's a question, and maybe it's not for you, maybe it's more for Andy, but you raised some really good questions about the future of CSPP Geo and the future of the framework because of this migration toward standalone systems and toward the cloud. So been so much effort that's been invested in the ASF framework over the years. It traces its legacy back to GeoCat and CleverX. And you know, we've done a lot of work on making it so that algorithms can be intercompatible with multiple systems. There's a lot of institutional knowledge, I guess, but just a lot of work that's going on. So it would be a shame to see the framework just disappear, I think. I can see it.
Yeah.
I don't even know what that is. This one. You know, to me, if it's a migration towards standalone programs that are like what Mike Lotus was talking about yesterday, that are clearly superior. The enterprise programs, the enterprise software that supports multiple satellites, and we could have joint video, geo, CSPP releases, that all seems like progress. But if the framework is dropped because it's not convenient, it doesn't work in the cloud, then that's going to have a lot of impacts on how we're developing things. So I was wondering, what is the plan of the framework?
Well, I don't know, but I'm a very interested party, and I actually don't understand the functionality of the framework doesn't go away. So, how it builds. Those are big questions. I know the program, you know, I think the level 1 will stay in a similar system, GeoXO as it is in GoSR. So that won't probably go. The processing will come up. Level 2 will be. And yeah, I don't know. I actually, we're both a developer and a support sponsor. I don't know. Those questions are being asked. I think, you know, you guys are experts, and I think NOAA would benefit a lot from their expertise. That's fine, too. Assist as well.
Thank you. And just to
Mike have a lot to say.
well, I was just going to say, even in the near term, if it sounds like the plan is meant not to add new features, maybe just maintain the framework. But so that could have an impact on us. We can't get new features.
Yeah, I mean, one of the things that I feel is somewhat of a missed opportunity over the last 10 years or more is, you know, really focused on building these sort of monolithic processing systems for satellite, for getting these satellite products out. And in reality, you know, maybe it should be more about a collection of libraries that developers can bring together in highly customized ways, so you can have these higher order thematic systems, and you're not starting from scratch when you're building them. You know, we shouldn't have 3 different versions of ingest software for a certain type of satellite data, but we do. Same thing with ancillary data handling. There's so many common operations that have to happen, but we don't have a centralized, clean, and well-maintained library that allows people to bring together systems like that. Instead, it's like, well, you got to either have CleverX or GeoCat or the framework, and they're not really set up like that. So I just think, especially if we're going to, you know, we're going to try to get at higher value applications, that's just going to be critical, but I just haven't seen any movement on it. If anyone would love to comment on that.
Yeah, so that is what we're working towards. So while we'll have standalone algorithms, we want to have a standardized set of libraries that can be shared between them. But yeah, this transition away from the framework is definitely not going to happen overnight. As long as the GoSR ground system is using it, we'll be supporting it. But as for new features, that I am not sure about at this time.